Okay guys, so I hope you have revised the by parts formula. Let's begin with the discussion of question on integrals from by parts. So the question is asking us to find this particular integral log x plus 1 by log x whole square. Now this immediately demands for by parts. What do? I can write this integral as two parts. Okay, so I will consider this as I and I will write it as integral of log x dx plus integral of 1 upon log x whole square dx, right? I will be considering this as I1. So let's separately solve I1. I1 is integral log x. Now this is one thing, log of log x, that's it. Log of log x, it's not product of two functions, it is log of log x. And therefore I write it as this into 1 dx. Whenever there is log, that's what we do. So what I do, I consider this as my first function, I consider this as my second function and I apply by parts. So integral of first into second, apply by parts. First function into integration of second, which is x, integration of 1 dx is x. So first function into integration of second minus integration of differentiation of first function. So d by dx of log x into integration of second function dx. So how do I remember it as? First function into integration of second minus integration of big bracket start d by dx of first function into integration of second big bracket close the whole dx. So here I get what? X log x minus integration of, what is differentiation of log x? It is 1 by log x into d by dx of log x, which is 1 by x into x dx. So this x cancels out. What are you finally left with? You are left with x of log x minus integral of 1 by log x dx. So in here, in order to evaluate the correct value of I1, I consider this part as I2. And now I separately solve I2. So I consider I2, it is integration of 1 by log x. Again, this is one single function, right? 1 by log of x. So I write it as this into 1 dx. This is now playing the role of my first function. This is algebraic function x to the power 0. By ILATE we know this comes first, this comes second. By ILATE, log comes first, algebra comes second. Why 1 is algebraic? Because 1 can be written as x to the power 0. Okay, so this is logarithmic, this is algebraic. So by ILATE, L comes first, A comes second. So here I write first function into integration of second, integration of 1 is x, minus integration of big bracket start d by dx of first function. So d by dx of 1 by log x is minus 1 by log x whole square. So d by dx of 1 by log x is minus 1 by log x whole square into d by dx of log x, which is 1 by x. Fine, I have just applied chain rule, nothing else. So minus integration of big bracket start d by dx of first function into integration of second big bracket close the whole dx. So this gives me x upon log x. This is plus, this x cancels out, this is integration of 1 by log x whole square dx. This is my I2. So now that I have got my I2 and this is my I1, I can write my complete I as what? I will be, what is I1? I1 is this thing minus I2. So this thing is x log of log x minus I2. So minus x by log x minus integral of 1 by log x whole square. Okay. This is what you have as your I2 plus. So this is I1. I1 was this minus I2. So I have written this thing minus this thing, which is my I2. Yeah. Plus, so this is dx, plus integral, what is left out, 1 by log x whole square dx. You can clearly see this and this get cancelled out completely, and your answer is x log x minus x by log x plus constant of integration. That's how bypaths get used twice, that to the one with the log, wherein you create the second function, that to algebraic, and then apply isolate and proceed ahead. Okay, let's talk about the next question. We now begin with application of integrals and look at this question, which is evaluating of area under the curve. So let's try to read the question and see what it is trying to demand, because the figure is not given to us. It is saying AOBA is the part of the ellipse whose equation is given to you just in the first quadrant, such that OA is 2, OB is 6. Find the area between the arc AB and chord AB. So if you talk about the ellipse, 9x square plus y square equals 36. Divide both sides by 36, you get x square by 4 plus y square by 36 equals 1. So what is this ellipse? It's very simple to identify. It is an ellipse something like this. This is O. This coordinate would be 0, 6. This is 0, minus 6, because you have y square upon 6 square. This is x square upon 4 square. So along the x-axis, this will be 2, 0. This will be minus 2, 0. Okay? It is saying OA is 2. So only in the first quadrant the question is asking us to consider the region which is given by the ellipse. So OA is 2. Of course, this distance is also 2, this distance is also 2, but if it is talking about the first quadrant, that means this point is A and OB is 6, so this point is B. Find the area between arc AB, this is my arc AB, okay, and chord AB. So find the area between arc AB and chord AB. I wish to find this area. This shaded region I wish to find. Okay, this is very simple. How to get it? Well, I will be finding the equation of this arc and equation of this line, and then y equals equation of this arc, y equals equation of this line. Integrate it from 0 to 2 and I will be subtracting them, equation of the curve or the arc minus equation of the line. So equation of the curve comes from here only. You have y square equals 1 minus x square by 4. 1 minus x square by 4 means 4 minus x square by 4, and this is y square by 36, so here you have 36. This gives you 9 times 4 minus x square. This is your actually y square. Now y would be plus minus square root of 9 times 4 minus x square, but minus is not going to come because we are only in the first quadrant. So x and y both are positive. So this gives you square root of 9 times 4 minus x square, which is 3 times square root of 4 minus x square. This is the equation of arc AB. Fine, equation of arc AB. Now what is the equation of line AB? You know that if a line is passing through 2 points, you know the equation of the line. It is what? Y minus y1. So let me take this as x1, this as y1, this as x2, and this as y2. So you have y minus y1 equals y2 minus y1, 6 minus 0, upon x2 minus x1, 0 minus 2, into x minus x1. So this gives you y equals minus 3 times x minus 2, which is y equals minus 3x plus 6, which is 6 minus 3x. So y equals 6 minus 3x. This is the equation of chord AB. So you have equation of arc AB, equation of chord AB here. This is from 0 to 2, x is ranging from 0 to 2. So area of shaded region, becomes equal to integration from 0 to 2 arc AB minus integration from 0 to 2 chord AB. I am varying x from 0 to 2, right? So here you have arc AB is what? Y equals 3 times root over 4 minus x squared. This is x equals 0, x equals 2. This dx minus integral from 0 to 2, 6 minus 3x dx. This is x equals 0, x equals 2. Okay, easy enough. 3 comes out. What is integration of 4 minus x square? This is integration of 2 square minus x square. Integration of square root of a square minus x square is x upon a under root of a square minus x square plus a upon 2, a is 2, right, plus a upon 2 sine inverse x upon a, that is it. So this is your integration of 2 square minus x square with a square root. It is x upon a root over a square minus x square plus a upon 2 sine inverse x upon a plus c. So here you have what? Minus, this is 6x minus 3x square by 2 from 0 to 2, and this is also from 0 to 2. This integration of 6 is 6x and integration of 3x is 3x square by 2. So this is what you have. So here what is it that you are left with? 3 times 2 comes, 2 upon 2 is 1, but here when 2 comes this is 0, so this entire thing becomes 0. This complete thing is 0. This is 1 times sine inverse of 1, 2 upon 2 is 1, sine inverse 1 is pi by 2, so this is pi by 2. And 0 when you plug in everything becomes 0, so not a problem. Minus this becomes 6 into 2, 12, minus 2 into 2 is 4, 2 into 2 is 4, 4 upon 2 is 2, 3 into 2 is 6. That's it. This becomes 3 pi by 2 minus 6 or 3 pi minus 6 by 2. That's what you have. You have thrice of this. This becomes 3 times pi by 2 minus 0, so it is just pi by 2, and this is minus 6x minus 3x square by 2, so this becomes 6 into 2, 12, minus 3 upon 2 into 4, right? 4 into 3 is 12, 12 upon 2 is 6, so 12 minus 6 gives you 6. Is it clear? This becomes 3 pi minus, let me write it as 3 pi by 2 minus 6. Fine. Of course, this will be 3 pi minus 12 whole upon 2, rest it would be 3 pi by 2 minus 6, that is it. Okay, so you can clearly check it once more. What is your answer actually coming? But this is how you solve it. The procedure is this only. Okay, so I have told you the drill. Of course, if there are any calculation problems, you can certainly sort that out by yourself. After this, the question says, find the area bounded by the curve y equals cos x between x equals 0 and x equals 2 pi. Okay. So between x equals 0 and x equals 2 pi, let's see what is and how is the curve of cos. So from 0 to 2 pi, let's see, that is how cos looks like. This is 0, pi by 2, pi, 3 pi by 2, and this is 2 pi. This is the graph of cos x. So if I wish to integrate from 0 to 2 pi, that means I want to find this, and let's drop a perpendicular, this. I have to find the area of this shaded region because it's written find the area bounded by this curve between x equals 0 and x equals 2 pi. So this is x equals 0, this is x equals 2 pi, between x equals 2 pi, this is the area which is bounded by the curve y equals cos x. Now one thing please try to understand, it's very simple to actually compute this area, but there is one flaw which students commit over here. Area of this shaded region, is actually equal to area of first region plus area of second region plus area of third region, right? So you add this area with this and you get the area of the complete shaded region. But because this part is below the x-axis, when you will be integrating, you will be getting a negative real number as the answer of this portion's area, the second portion's area. But area can never be negative. So whenever you have the region which is below the x-axis, you do what? You take the mod of that integral. So integral pi by 2 to 3 pi by 2 of cos x which is going to give me the area of this second region, I will take mod of that integral so that I get non-negative value as the area, and when I add it to these two non-negative values, my final answer of this complete shaded region's area is a non-negative value. Okay, that is the only thing. That I am only going to do with the second region's area, not with the first or with the third, because they both are already above the x-axis, so it is already going to give me my non-negative area. So what is area of the first region? 0 to pi by 2 cos x dx plus pi by 2 to 3 pi by 2, pi by 2 to 3 pi by 2 cos x dx. This I will take mod of, I told you why. And thirdly, I have 3 pi by 2 to 2 pi cos x dx. Okay? In here, this becomes sin x from 0 to pi by 2 plus sin x from pi by 2 to 3 pi by 2 mod plus sin x from 3 pi by 2 to 2 pi. Okay. So, sin 90 is 1, sin 0 is 0. Okay. Sin 3 pi by 2 is minus 1 minus sin pi by 2, which is 1. So, minus 1 gives you minus 2, mod of minus 2 gives you 2. And here you have sin 2 pi is 0 minus sin 3 pi by 2, which is minus 1. So, 0 minus minus 1 gives you 1. So, you get 4 square units as the answer. Okay, the only drill was that here this area is coming, or this region is coming below the x-axis, so you better take the mod of this value. Otherwise, just imagine if you would have not considered mod, this is coming minus 2. So, 1 minus 2 plus 1 would have given you 0 as the area. That means it is not sweeping any area. But you can see by the figure it is sweeping a lot of area. How can the answer come out to be 0? So, of course, that is the wrong answer. And what is the wrong thing that you have committed? You have not taken the mod. That's how important it is. Your complete answer can become a blunder. From 4, it can straight away come out to 0, which is directly visible is a wrong answer. Okay, so don't commit this mistake. Let's talk about the next question, which is from differential equations. And what is it trying to say? It is asking us to form a differential equation of the family of circles touching the x-axis at origin. So these type of questions on formation of differential equations are very important. In here, if you try to analyze what's the picture going on, the family that they are trying to ask us to consider is the family of circles which touch the x-axis at origin. So if you can consider this family, it can go on and on. If you consider this family of circles, two things are there. These circles are passing through origin and their centers are lying on the y-axis. Okay, the centers are lying on the y-axis. So therefore, their centers are going to look like 0, a for some a on the real line. Fine, so their centers are going to look like this. So all these families, all the circles which are there in the family of circles touching the x-axis at origin are going to have their centers like this, and if the center is 0, a, then the radius also is a only because they are touching the x-axis at origin. So whatever is the radius, that itself is your small a. So radius is this a. So I will say that let C denote the family of circles. Let C denote the family of circles passing through origin, or you can write touching the x-axis at origin. Fine. Then 0, a represents the center of any member of that family, C. Therefore, equation of C is given by what? Equation of this family of circles with center 0, a, radius a, because they are touching the x-axis at origin, is given by what? What is the general equation of a circle? X minus 0 whole square plus y minus small a, the next coordinate of the center of the circle. X minus 0 whole square plus y minus a whole square equals radius square. This is my equation of the family of curves, which are my circles touching the x-axis at origin. So this will be x square plus y square plus a square minus 2ay equals a square. This gets cancelled out. So x square plus y square equals 2ay. But over here a is present, and you know that while forming differential equations we get rid of this constant. How many ever constants are there? We differentiate our equation those many times to get the differential equation free from a, representing my equation of family of circles. So here only one constant is there, so I will be differentiating this only once. So I will get 2x plus 2y dy by dx is equal to 2a dy by dx. From here I will find the value of a. I can see that 2 comes out common from both sides and get cancelled. So you have x plus y dy by dx upon dy by dx equal to a. So now what I do, I put this value of a in 1 so that I get a differential equation which is free from a. So what is it that I get? I get x square plus y square equals 2y into a, which is x plus y dy by dx whole upon dy by dx. So this dy by dx comes over here. You get x square dy by dx plus y square dy by dx equals 2xy plus 2y square dy by dx. So 2y square dy by dx minus y square dy by dx gives you y square dy by dx. When you bring it again over here, you get x square minus y square dy by dx equals 2xy, and therefore your dy by dx becomes 2xy upon x square minus y square. And this is that differential equation free from any arbitrary constant, which represents your family of circles which are touching the x-axis at origin. Is it clear? That's how you form the differential equation, by realizing the concept that how many ever arbitrary constants are there, those many times you differentiate and hence get rid of this constant. Coming up next is another question from differential equations. It is asking us to find the equation of a curve passing through this point, given that the slope of the tangent to this curve at any point is 2x by y square. So any point x comma y is there on the curve, and the tangent to the curve at that point is given like this. Now you know that if there is a curve, then tangent to the curve at that point, any point x comma y, its slope is given by dy by dx. So it is given that slope is this, but actually slope is given by dy by dx. dy by dx is the slope of the tangent at the point x comma y to the given curve y equals fx, okay, for some point x comma y I am talking about. And that slope at some point x comma y is given as 2x by y square. From here I can solve and find the equation of the curve. So let's do that. What do? It's clearly visible that it is a variable separable type. So I separate the variables and I do this type of variable separable integration. So this gives me y cube by 3 equals 2x square by 2 plus c, which gives me y cube by 3 plus equal to x square plus c. Okay. Once you have got this, you exactly haven't got the equation of the curve. I have to find the equation of the curve. What is unknown to me is this constant. But there is a fact given to me that the curve is passing through minus 2 comma 3. If this is the equation of the curve and this curve is passing through minus 2 comma 3, that means in place of x if I put minus 2, in place of y if I put 3, this equation gets satisfied. So you get 3 cube upon 3 equals minus 2 square plus c. 3 into 3 into 3 is 27 upon 3 is 9, which is equal to 4 plus c, or c is 9 minus 4, which is 5. So your equation of the curve is what? Equation of curve becomes y cube by 3 equals x square plus 5, or you can say y cube equals 3x square plus 15. So now x square is already non-negative, so 3x square plus 15 is non-negative. So y becomes 3x square plus 15 whole to the power 1 by 3. I have taken cube root. Is it clear? So this is what you have as the final equation of the curve, which is passing through the point -2, 3, and the slope of the tangent to this curve at any point x, y is 2x by y square. Okay, just see how the question was not directly talking about differential equation, but then it does get created, and therefore you demand the variable separable type, so you should be able to identify, proceed ahead with the solution, find the value of c, and you have your answer. Easy question, not that tough. Let's move to the next question. It is saying that show that this differential equation is homogeneous and find its particular solution. So, finding particular solution or finding general solution is a question which is very much asked in the paper. So, here if I have to identify whether it is homogeneous or not, step by step we are going to proceed. I will first be writing dx by dy. So, right now the equation is giving me in a mixed form. I will write dx by dy. So, first of all I write 2y e to the power x by y dx is equal to minus of y minus 2x e to the power x by y dy. So, my dx by dy becomes what? My dx by dy becomes what? It becomes, so it becomes minus of y minus 2x e to the power x by y upon 2y e to the power x by y. You can see 2y to the power x by y dx is equal to minus of y minus 2x e to the power x by y dy. Okay, that's what you have. So, in here if this is my dx by dy, please try to understand how am I going to conclude whether it is homogeneous or not. First of all, I need to define this as my function of x and y. This whole upon 2y e to the power x by y. Now, I will replace x by lambda x, y by lambda y. So, I get f of lambda x comma lambda y. This becomes minus of lambda y minus 2x, x will be replaced by lambda x e to the power lambda x by lambda y. Whole upon twice of lambda y e to the power lambda x by lambda y. So, one thing is clear that lambda comes out common from the numerator and gets cancelled with lambda from the denominator. Lambda x by lambda y gives you just x by y, lambda x by lambda y gives you just x by y. So, you are left with minus of y minus 2x e to the power x by y whole upon 2y e to the power x by y, which is what? Which is your function f of x comma y. So, you will write it as lambda to the power 0 f of x comma y, which eventually means that this is a homogeneous. This is definitely homogeneous differential equation with degree 0. With degree 0. It is homogeneous with degree 0, or you can say this is a homogeneous function in x and y with degree 0. Okay, the moment I have identified this is homogeneous function or homogeneous differential equation, how do we proceed further? If I know now that this is a homogeneous differential equation, how do I proceed further? I have got my dx by dy with me. So, I wrote this, equated it with minus of this, right, and then dx by dy I evaluated. So, over here I have got this times dx equals this times dy. Now, what am I going to do next? If this is confirmed that this is homogeneous, what am I going to do next? You substitute x equals vy. That's the drill, that's the algorithm, and now you differentiate both sides with respect to y. So, you get dx by dy equals first function into d by dy of y, which is differentiation of the second function, which is 1, plus second function into differentiation of the first. So, you will be replacing dx by dy with this. So, both these substitutions you are going to use over here. So, dx by dy will be replaced by v plus y dv by dy, okay, v plus y dv by dy equal to minus, so over here also what is going to happen? I can write this as 2x e to the power x by y minus y. So, let us write it like that, that is going to be more familiar. I will be replacing x by vy. So, this will be 2 vy e to the power vy upon y minus y whole upon 2y e to the power x is vy upon y. So I wrote this as 2x e to the power x by y minus y upon 2y e to the power x by y, and everywhere wherever x was written I replaced it by vy. So this becomes 2 vy e to the power vy by y minus y upon 2y e to the power vy by y, and over here I replace dx by dy by v plus y dv by dy. So everything now is in terms of v and y. Previously everything was in terms of x and y. Now we have everything in terms of v and y. Now we are going to solve it in terms of v and y only, and then we are going to replace y by x by v or v by x by y, so that then again we are going to have everything in terms of x and y. So here let's solve it. You have y dv by dy equals, if you can carefully see, y and y comes out common from the numerator and gets cancelled out with y from the denominator. So then you have 2v e to the power vy by y is just v upon 2e vy by y is just v, and then you have minus v. So this gives you 2v e to the power v minus 2e to the power v into v upon 2e to the power v. That's it. You have got what? Yeah, so here it will be 1 actually. So one step is missed out. Let me write it first, that step. So here you had this minus 1, okay, so 2v e to the power v minus 1 because y came out common, so this is 1 upon 2e to the power v minus v. So this gives you what? Y dv by dy equal to 2v e to the power v minus 1 minus 2v e to the power v upon 2e to the power v. Clear? 2v e to the power v, 2v e to the power v cancels out, you are left with minus 1 upon 2 e to the power v. Now you can clearly see I have dv dy, this is completely expression of y, this is completely expression of v. Separate the variables out and perform your integration. This is 2 e to the power v dv equals minus 1 by y dy. Integrate both sides. Fine, by using variable separable form. So this is 2 e to the power v, because you know 2 comes out and integration of e to the power v is e to the power v, is equals to minus, what is integration of 1 by y? Log y plus integration constant or constant of integration. Now what I do is I replace v by x by y. So I get twice of e to the power x by y equals minus ln mod y plus c. This is my general solution but not particular solution. I have to find the particular solution when x is 0 and y is 1. So when x is 0 and y is 1, so x is 0, put x equals 0, 0 upon 1, this will be minus log 1 plus c. So you will get 2 e to the power 0, e to the power 0 is 1, so you get 2 is equal to minus, what is log 1? 0. So 2 is equal to 0 plus c, you get c is equals to 2. Therefore, particular solution turns out to be what? Particular solution turns out to be what? 2e x upon y is equals to minus ln mod y plus 2, because c's value is 2 when x is 0 and y is 1. Is it understood? This happens to be your particular solution. That's how the question is not just making you revise the concept of homogeneity or how to solve homogeneous differential equations, but it is also asking you to recall the concept of finding the particular solution if the general solution is known. What makes general solution a particular solution is just the value of this constant, which you get by these. That is why it was important for me to first replace v by x by y, because if over here only I would have started finding the value of c, I wanted to substitute x0 and y1, but there is no x, there is v, right? There is no x, there is v. So I first converted v as x by y, I got everything in terms of x and y, and then after proper substitution I got the value of c. So from this step, come to this step and then evaluate the value of c. Don't start evaluating value of c at this step when you have expression in terms of v and y, because v's value you don't know. You know the value of x and y. So from v come to x and y, plug in the values of x and y, get the value of c, and then declare this entire expression in terms of x and y and a fixed value of c to be your final particular solution. Is it clear? We're going to move ahead and discuss some more questions from the left out chapters, and that is going to actually lead us somehow to the end of our crash course because we are hardly left with any chapters. So stay tuned. We're going to meet in the next session. That's it from my side. Thank you.